Okay, the purpose of this video is to review basic information that you will need to do well on a polar FRQ. The first formula we're going to go over is the formula for area. I know you guys just took a test on this, so this should be this formula should ring a bell for you. It's 1/2 times the integral from alpha to beta of r squared d theta. Now, area is the consistent question that will come up on a polar FRQ, so you can count on it for probably your first or second question, and anywhere from 2 to 4 points. So there's a couple pieces let's talk about this formula. So one thing you need to make sure that you remember is that alpha and beta are theta values. Okay, now sometimes these are given in the problem. So we'll say underneath, we'll say given, or use the trace button on your calculator to find those. So you want to make sure to trace the curve out. When you are calculating this, we'll say to calculate, the calculator needs to be in polar and radian mode. Okay, so the AP board, when they're grading, they're going to expect that you give your final answer in radians. And then finally the last piece, I'm going to put this in a different color here, is talking about in the case that you need to find an intersection point. Now oftentimes the intersection points, where one graph will cross another one, if you need to find an intersection point, this is not common, we'll do this actually in one of the problems here, but when you find an intersection point, you need to be in function mode. There is no way to find intersections in polar mode, even if you're looking at the graph. So you need to kind of pull out of the graph in polar mode, switch it to function mode, and then just work with your equations a little bit differently. And there'll be some good examples of that as we move through the 3 FRQs here. Other equations that you want to make sure you have down are the equations for x and y. So we'll say other formulas. You want to have x equals and y equals. X is equal to r cosine of theta. Y is equal to r sine of theta. Anytime you get asked a question about x and y, these formulas are necessary. And what you do is you just plug in your r polar curve given to you. The other one you want to make sure you have down is that dy dx is equal to dy d theta over dx d theta. I'm going to talk a little bit more about what dy dx means, but I will make a little note here is that you can find on the calculator once the polar curve is graphed. So when we find dy dx, you go to second trace and it will calculate out dy dx for you. So the Math 8 button won't work to find dy dx. It will only work once the polar curve has been graphed. And then I'll just say second trace. And then you'll be able to get dy dx. So those are the big formulas we want to make sure we have memorized. Now, having the formulas down is one thing. Another thing that we have happen on a lot of these polar FRQs is you're asked to interpret certain values. Okay, so I'll label this little section here, interpretations. Okay. So a lot of different things we might need to interpret. We'll start with dy dx. I gave the formula for that above, but dy dx is going to give the slope of the tangent line to a polar curve. Okay, dy dx gives the slope of the tangent line to a polar curve. So if you see the words tangent line or slope, you need to find dy dx. If you go to Math 8, or you also graph a polar curve and go to that second trace button, another option that you have is to find dr d theta. So the question is, what does dr d theta actually represent? So r represents what we call the radius. So if we find dr d theta, this tells us how r, which is equal to the distance to the origin, how r is changing with respect to theta. Okay, how is r changing with respect to theta? So for instance, an example. If dr d theta is greater than 0, what that means is that then the distance to the origin is increasing. Okay, if dr d theta is greater than 0, then the distance to the origin is increasing. And when we say the distance to the origin, we're saying the distance that the polar curve is away from the origin. That distance is increasing. Similarly, if dr d theta was less than 0, it would mean the distance to the origin is decreasing. So the key here is that you remember that r represents the distance to the origin. So we've got dy dx, dr d theta, and then we also have dx d theta. It's another thing that can come up. So for dx d theta, now we want to know how x is changing with respect to theta. X, if we think about on a graph, x represents the distance, the horizontal distance to the y-axis. So we'll say how x, which is the distance to the y-axis, is changing with respect to theta. It's how x, which represents the distance to the y-axis, is changing with respect to theta. So an example, if dx d theta is less than 0, then the distance to the y-axis is decreasing. Similarly, we could say if dx d theta is greater than 0, that the distance to the y-axis is increasing. All right, now if we have dx d theta, we of course also have dy d theta. Okay, so dy d theta is how y, which represents the distance, this is going to be a vertical distance now because we're talking about y, the distance to the x-axis is changing with respect to theta. And the interpretation would be very similar as to these last two examples. Now, something we need to make sure that we pay attention to is that these two values, dx d theta and dy d theta, right down here, dx d theta and dy d theta, we will find in function mode with the formulas for x and y. Okay, so what I mean by that is once you have these two formulas using x and y, you can plug those in to function mode, and then you would use Math 8. Math 8, you do n derive, and then you could just plug in your theta value, and it would, in function mode, it will give you these two values. So that's an important calculation step to remember. And we have not had much practice with this, so this is really getting to be our first practice with this topic, or those pieces. All right, a couple of the things that could show up. These are kind of the more of the rarity ones, but if we need to find the distance between two polar curves, you would just subtract the two formulas, or subtract the two curves. Okay, so if you need the distance between two polar curves, subtract. And finally, the last thing that could potentially show up. If we need to, you might get a question that says, find the max or minimum distance from the origin. Okay, find the maximum or minimum distance from the origin. So first off, maximum or minimum, we are talking about an absolute minimum or maximum. Second thing here is we're talking about the distance from the origin. We are talking about what r is equal to. So the process we would go for to find this is we'd use our absolute minimum or maximum process, which is really a two-step process. We need to find the critical values. So find the critical values using r prime of theta equal to 0. This part here, this r prime of theta equal to 0, this can be tricky, and to do this you will need to have your calculator in function mode. So you find the derivative and then set it equal to 0, but you can find the 0 on the second trace menu, but you have to be in function mode in order to do that. Then our second step, once you have those critical values, you're going to make a table with critical values and endpoints. That table will look something like this. It will have theta values, and then it will have r of theta. And you fill in your theta values, and the biggest or smallest r of theta value will be your minimum or maximum. So if you can handle all these or portions of these, you're going to make sure that you will get a good chunk of points on these problems. All right, so now let's practice some problems.